Kind of got you started with this on the warm-up in the previous lesson, but today we're going to focus our time on how to compare and order fractions. They may look different. We should be able to figure them out, though, moving forward. Go ahead and write this down, and hopefully you have today's date and page number also in your notebook. Here is your warm-up. Find the missing value of all four fractions. So again, use what you know to be able to find what you don't. Come back when you're done. And here are the answers you should have gotten. So for number 1, you changed it from 3/5 to 9/15. Number 2 went from 2/3 to 8/12. Number 3 went from 3/4 to 15/20, and number 4 went from 5/8 to 15/24. All right, let's get into our new knowledge today as we move forward. Here are a few notes that I want you to make sure you write down. Now, when you're comparing things, remember, you're trying to see what's different about them. And if you're ordering them, we usually put the lowest value to the highest value or vice versa. So when we're comparing fractions, the first thing you want to always look at is the bottom number or the denominator, D down. So when fractions have the same denominator, we call those like fractions. So here is the first definition I want you to write down. And here it also gives you two like fractions. You can see 6/7 and 4/7. If you look at their denominator, they're the same. So it makes it real easy to be able to compare which one's bigger, because once the denominators are the same, all you got to look at is the numerator. Now, when fractions have different denominators, we call them unlike fractions. So an example here would be 7/10 and 1/2. The 10 and the 2 are not the same number, obviously. So they're called unlike fractions. That's good to know because that's two phrases I'm going to use as we move forward, like and unlike. Have this down before we move on. Now in example 1, we're going to look how you can compare two different fractions. So let's say we were looking at 6/7 and 4/7, and we had to compare if one is less than, greater than, or equal to. Now, I could make a drawing if I think I need to, something that has 7 equal parts, since both have a like denominator. These are like fractions. Common denominator, they are called like fractions. So if we look at this, we can see out of the 7 chunks, 6/7 has 6 pieces filled in. I put a green line, maybe I should use a different color. The other one has 4. So by doing a drawing, you can clearly see that 6/7 is greater than 4/7. But if we think about a number line too, we know that 6 is further to the right on a number line than 4 is. And if that's the case, that would mean it's greater. So I could draw a number line to show this as well, 6/7 being greater. All right, write this down if you think you need an example. All right, here's another one. Let's say we had like denominators, like fractions here. And you can see that we have 1/9 and 5/9. Again, I made 2 drawings to help you. A pie broken into 9 pieces is what I did. And if we look here, the 1 looks a lot different than the 5. You can see that 5/9 is greater. But again, thinking on a number line, 5 is further to the right than 1 is. So when you have like denominators, or common denominators here, 9 and 9, it makes it real easy that all you got to do is look at the numerator to be able to compare which one's greater than, less than, or equal to. All right, so most of these have common denominators or like denominators, so it shouldn't be too hard to be able to figure out which one is greater than, less than, or equal to. Now, I've told you in previous videos, for the ones that are unlike, like number 12, you see has a 4 and an 8. You can look at the difference between the numerator and the denominator. The closer the numerator and the denominator are, the closer they are to being whole, which is different from the other number. So try your best with those. I will show you how you can make a common denominator in example 2. But go ahead and try to tell me whether all these are less than, greater than, or equal to. Good luck. Here are the answers you should have gotten for these. So if you look at it, the trickiest ones were probably 12 and 16, and 15 maybe. But that one should look pretty similar to half when you see the numerator is halfway to the denominator on both of them. For 12, 3/4 means you have 3 parts to make 4 to make a whole, where the other one is 3 parts out of 8. So it's not as great on the right side as it is with the left side. And for 16, you can see 4/8 is halfway there between 4 and 8, and 16 to 24 is a lot closer, so that makes it greater. If you got all those right, come on over and give me a high five. All right, I started using this word common denominator, this phrase, not word. Common denominator a little bit in practice and example 1. But let's make sure we have this definition down. So to compare unlike fractions when you don't have models or drawings to look at, you have to rename your fractions so that they have the same denominator. We call this finding the common denominator. Okay? This is a method that can be used to compare mixed numbers as well. Probably shouldn't put the bracket there. I want you to copy down that whole thing because the first part is the definition, and you could end here, but the other part says, hey, we can use this with mixed numbers like 3 and 2/4, stuff we learned in the previous lesson. Anyways, make sure the definition's down before moving on. Okay. So in example 2, I have no drawings here, but let's say we're looking at Ray. Ray has 2/3 cups of nuts, and he needs 3/4 to make some cookies. Ray, I hope you're making cookies for me. Does he have enough nuts for the recipe? Well, we have to see if 2/3 is equal to or greater than 3/4. So the first thing we have to do is we have to find a common denominator by simply just doing one thing. Multiply the denominators together. That's the easiest way to get a common denominator. So 3 and 4 are denominators. When we multiply those together, you get 12. So now we're going to try to make 2/3 into something 12ths and 3/4 into something 12ths. So how do we do that? Well, if you remember from a previous lesson when we were finding equivalent fractions, all we have to do now is figure out what we did to the bottom to get from 3 to 12. We are getting bigger, so we had to multiply. What we do to the bottom, 3 times 4 gives us 12. We have to do to the top. That's why here 2 times 4 gives us 8. So 2/3 has an equivalent fraction of 8/12. Now, to make sure we can look at 2/3 and 3/4 with common denominators, we have to do the same thing with 3/4. 4 times what gives us 12? That would be 3. What we do to the bottom, we do to the top. 3 times 3 is 9. Now when we look at it, we're looking at 8/12 and 9/12, so we're looking at two fractions that have like denominators, common denominators, and now we have like fractions. So if I was to ask you, does Ray have enough nuts for his recipe? The answer would be no, because he needs 9/12, but he has 8/12. So no, he doesn't have enough. He's close. He's only 1/12 away, so he's going to have to go to the store or see if someone can borrow him some nuts to be able to make all those cookies, because Mr. Singer's hungry. He needs his cookies. Okay, let's look at another one. This time Trevor has 1/3 cup of soil. He needs 1/4 to fill a small planter. So again, we have unlike denominators or unlike fractions. We have thirds and fourths. So the easiest way to do it is you multiply 3 times 4 to get 12. Oops. Now that we have 12, we know that that's going to become our common denominators. So we got to take 1/3 equaling something 12ths and 1/4 equaling something 12ths. So again, what do we do to 3 to get to 12? 3 times 4 gets us 12. What we do to the bottom, we do to the top. 1 times 4 is 4. 4 times what gets us 12? That would be 3. What we do to the bottom, we do to the top. 1 times 3 is 3. So now, Trevor had 4/12 or 1/3 cup of soil. He needed or needs 1/4 cup or 3/12. So does Trevor have enough? The answer is yes, because he has a value of 4/12 and only needs 3/12. So he actually has more than he needs. All right. Now we did some with me. It's time for you to do 2 on your own. Go ahead and figure out if Arsenio if he has 2/3 cups of brown sugar and he needs 1/4 cup, does he have enough? Show your work to explain. And for the other one, Kelly needs 2/3 gallons of paint to finish painting the deck. She has 5/8. Does she have enough paint to do it? So you got to make common denominators and then figure out if your numbers work. Come back when you're done. All right, so Arsenio does have enough brown sugar for the recipe. He has 8/12. I made common fractions, or like fractions with common denominators. So we have 8/12, and 3/12 is what his recipe calls for. So 8 is greater than 3, so yes, he has enough. Now Kelly, on the other hand, doesn't have enough, because I multiplied 8 and 3 at the denominators to get like denominators of 24. And when I made sure everything was equivalent, Kelly needs 16/24, but only has 15/24. So because of the difference, we can see that Kelly does not have enough. All right, so taking what we learned in the second example here, if we were to order, and we had this as a warm-up in the last lesson, if we were to order 4/5, 2/3, and 1/3 from least to greatest, how can you do this? Well, we know that all of them are fractions, so they are some number that fall between 0 and 1. So what we need to do is find out which ones are smaller than greater. So the first thing you want to do is you want to find common denominators. So remember, all you have to do is multiply the denominators to get what you have. Now, that doesn't mean we have to multiply 5 times 3 times 3. If two of them are thirds, we are going to keep thirds, and we're just going to multiply it by 5. So 5 times 3 gives us 15. That's how I was able to get 15 as denominators there when we create like denominators, like fractions. So now all we have to do is multiply whatever it is to the numerators to get it to be correct. So 4/5 changed to an equivalent of 15ths is 12/15. 2/3 becomes 10/15, and 1/3 becomes 5/15. Now, on a number line, I can show this by taking the amount of parts it takes to make one whole, being 15, and I could draw a number line between 0 and 1, and I'm going to draw 15 slashes, which makes for me how many parts it takes to make a whole. So now I'm just going to label them. 4/5 would be at 12/15. So when we go over to 12/15, we see that's a pretty large number, almost close to 1. And it is the largest. The next one is 10/15. So 2/3 is close to 12/15. It's only off by 2/15. Still smaller though. And 5/15 is what 1/3 is. So on a number line, I can draw them, and that will tell me which ones are least to greatest. You don't have to draw a number line, but it helps just to visually show what we're doing. That's why I did that. Okay. So I have a lot of problems on the board here, but I only need you to do 20, 21, and 22. The other 4 are there if you wanted extra practice. I'm going to do 19 with you just to show you another example. So the first thing I have to do is find a common denominator. So if I multiply 2 times 5 times 7, that's going to give me a common denominator. 2 times 5 is 10. 10 times 7 is 70. So I'm going to make 3 fractions that are 70s. So we're going from 1/2 to something 70s, 3/5 to something 70ths, and 3/7. So I got to find what to do. Well, if I start all the way at the left, how many times do you multiply 2 to get 70? That would be 35 times. So 1 times 35 is 35 70ths. Yeah, that's half of 70. Now, how many times do you multiply 5 to get 7? You would do that 14 times. What you do to the bottom, you do to the top. 14 times 3. 3 times 4 is 12. Carry the 1. So you get 42. And how do you get from 7 to 70? You multiply by 10. You multiply by 10, you get 30. So now we can see which ones are greatest to least. The smallest numerator we have is 30 70ths, which is 3/7. So that becomes our least. The next smallest is 35 70ths, or 1/2. And then finally, 42/70 is our greatest at 3/5. So for number 19, that's the answer. Okay, good luck with 20, 21, and 22. Come back when you are done. So here are the answers you should have received for number 20. It was 1/6, 1/4, and then 2/5. For 21, after I put them back to their regular fractions, it's 1/3, 3/8, and 4/9. And for 22, it's 1/4, 5/9, and 5/6. Now, I do want to ask you this question because this is to help you moving forward. Is there a better method than just multiplying all three of those denominators together? Is there an easier multiple for you to be able to find from those three? Hint, hint, the multiple part. I want you to think about that as we move forward. Here's your box of thought. Go ahead and answer these two. And here is your quiz. All 5 questions I want you to solve in your notebook. And that's it for today's lesson. And it's it for this short little Introduction to Fractions unit. So good luck moving forward on the review and all that other stuff and on the test. Don't forget to go back to your notes if you need extra practice as you move forward, and use your notes on your test as well. We'll see you next time.